Lesson 6.1, Exponential Growth and Decay Functions. Our essential question, how do you graph exponential growth and decay functions? There are 3 problems left on the page for independent practice. Let's go ahead and take a closer look at those. First, I'm supposed to decide whether this function is growth or decay. You do that by identifying the b. The b is the value that has x as its exponent. So my value of b is 1.5. Because b is greater than 1, I know this is going to be an exponential growth. So let's go ahead and graph it and prove that it is exponential growth. If it's growing, it should grow as we read it from left to right. So I'm going to use my tables. I have x values that I'm going to plug into the x value on my calculator and get my values. So -3 gives me 0.29. -2 gives me 0.44. -1 gives me 0.66. 0 gives me 1. 1 gives me 1.5. And 2 gives me 2.5. I see it looks like the numbers are getting bigger, so it appears to be growth. So let's graph it and verify. X's are both positive and negative. My Y's are only ever positive. So here's my x-axis and the y-axis, scaling by counting by ones. -3 is 0.29. And connecting it with a smooth curve, it does appear to be exponential growth. It is growing as you read it from left to right. Our next problem, we need to identify whether this is a growth or decay function. You do that by first identifying b. b is the value that has x as the exponent. So my value of b is 7/2. 7/2 is bigger than 1, which means this should be an exponential growth. So we're going to graph it and prove. If it's growing, it will go from left to right, and it will grow. So here's my table. I'm going to plug these x values into the x, and that will tell me how to graph it. So -3 is 0.02. -2 is 0.08. -1, 0.28. 0, 1, 1, 3.5, and 2, 12.25. My x's are positive and negatives, but my y's are only ever positive. So here is my x, here is my y. I'm going to scale my axes. -3, very little. -2, just a little bit more. -1, 0.28, 0, 1, 1, 3.5, and 2. 2 is 12, and it's like way off the page. So it started really slowly, but then it really took off. So here it is. It is a growth. Last problem. We're supposed to identify whether this is growth or decay. To do that, I need to identify b. b is the value that always has x as the exponent. My b is 0.8. Because b is between 0 and 1, that meant that this was an exponential decay. So that meant when I graphed it, it should be going down as I read from left to right. So I'm going to plug these x values into the function on my calculator. I get 1.9, 1.5, 1.25, 1, 0.8, and 0.64. X's have positive and negatives, but the y's are all positives. So here is my x, here is my y, scaling my axes. -3, 1.9, -2, 1.5. I see it is slowly going down, but it is decaying and going down. I meant this side was up here a bit. So it is decay, it is going down.